All right. Hal, can you shut the door? Thank you. The AC, man. All right. This is old news, right? But I want to remind you guys, here's y equals x squared in all its glory. What's the axis of symmetry? Zero. Be much more specific?
X equals 0.
Yes, x equals 0. Cool, I like it. And here the input is x, like we're used to, and the output's y. Does not have to be that way. I don't even have to use the letters x and y, but the most immediate thing is I could switch them, and then what would it mean graphically if I did? So what if I had x equals y squared? Right. So why is that point there? Because 1 squared is 1. Why is that point there? Because negative 1 squared is 1. So now my input is which variable? Yeah, y is my input now, right? So if I input 1 or negative 1, what x comes out? If I input 1 or negative 1, what's 1 squared? And what's negative 1 squared? Do you see how I put that number first? Because now it's acting like an input. And of course 0 squared is amazingly enough 0. So still, the vertex is still here, but now it's opening this way. What's the axis of symmetry?
Y equals 0.
Y equals 0. I like this. So now when the y is being squared, bless you, and not the x, it's just going to be parabola that opens this way. How would it make it open that way?
Negative.
Yeah, make it x equals negative y squared, amazingly enough. So that's our equivalent of up. Now it's opening to the positive direction. If it's positive, it would be opening negative direction. If it was negative, Steve, you look at me like you're crazy, which I'm used to. Are you okay?
Yes, sir.
All right, it's just your face went there. Okay. Yeah. All right. Nothing major. But let's kick this up. Yes.
Wait, the axis of symmetry is y equals 1?
I'm sorry. What did I say? Y equals 0. Thank you.
That's why I think that you
Oh, okay. You're allowed to then, because that was crazy. Good. So the axis runs right down the center. Y equals 0. Kick ass. Now, thankfully, no matter what the variable is, so if I make this a little bit more interesting, so you realize, so which direction, what's the fundamental shape going to be? Be very specific.
Down.
And when you say down, how do you mean? Yeah, down meaning back, right? So from your perspective, it'll be, what is your perspective? It'll be this way, right? It's going to open like this. Do I have a quick way to find the vertex? We do. You just have to be careful about what you label the letters.
negative b over
Yes, but now negative b over 2a is going to equal
negative 4.
y. Y is the part that's over here, isn't it?
Yes.
You see that? Why was it x before? Because x was the thing that was being squared and blah, blah, blah. Now y is, so when I do negative b over 2a, I'm going to get what y is. That's all, nothing major. Whatever the hell you call the variable that's in here, that's what you're going to get out when you do this. And then once I get it, how do I get x? Plug it in. It's crazy. So everything is exactly the same. It's just that the x and y are switched This is what the inverse would be, right? But it's not really an inverse because is this a function? Officially not. I'm throwing a lot of weird shit, but officially this is not a function, but it is. When I say that, normally I think y as a function of x. This is x as a function of y, which is still a function if you consider everything sideways, but in everyday life we consider that to not be a function because it doesn't pass the vertical line test. Let's stop there for a second. All right. So what is the y piece of the vertex? Negative 4 over twice
Negative.
-2, which is
Negative 1.
good, -1. So what's the x piece? -2 times -1 squared minus 4 times -1 plus 1. That would be -2 plus 4 is 2 plus 1 is 3. Is that cool?
-1.
Do it again, sir.
So -1, right? Or
Careful now.
3 negative.
Yeah, so the vertex is 3, -1. I'll let you absorb that. Because what's the x that I found? What's the x that I found? 3. It goes first. X always goes first when we do x, y. We didn't switch the axes. We were switching the graph. Right? So I found the y first. It goes in the y place. Then I found the x. It goes in the x place. You still plot this point the same as always. It's just that the result's going to be the other way. What else can I get? What can I get from the beginning?
Y,
Y.
the x
The x-intercept, because you're going to make y
equals
0. To make y 0, you get x is
1.
1. So the x-intercept, when y is 0, x is 1. You see how everything's just turned around?
And y-intercept you have to make it to 0 equals 0.
Exactly. So then you have to do quadratic formula and stuff. Let's see if we can handle this. All right. So we know it's going to look like something like that. All right. Just to make a gross, quick thing. I know it's going to look something like that. It's been moved around. So where's the vertex at? Yes, the vertex is at 3, -1. So 3, -1. From here, it's going to open that way, right? My x-intercept is 1, 0. Let me see if you guys can handle this. Here's the axis of symmetry, right? And what's that axis of symmetry's equation? Y equals -1. So where is there another point? Yeah, there's got to be another point the same distance away on the other side, right there. We found it the same way we did before. Herbal. So it's going to go through there, through there, through there. Blah, blah, blah. Yeah, good. To find these for sure, you'd have to use quadratic formula on this. Quadratic formula normally is x equals -b, but now, of course, it's going to be y equals -b plus or minus blah, blah, blah. So it's the same formula. It just gives you the other variable. Whichever one is the input variable, that's the one it gives you. I really don't want this to be a huge deal. It's just fundamentally shifting everything we know. But everything's exactly the same. It's just that all the x and y stuff is switched, which is what it should do, because this is sort of the inverse. All right. I'm going to impersonate you guys. When you're really happy. You ready? When you're really happy? When you're really sad? When you understand? And when you don't have a clue? You guys are so easy to impersonate. It's amazing. When you're putting up with your dorky math teacher. Let's see. All right. So the more interesting part is section 15.1. That's all I'm going to say on that. That's old news. Is circles. And sometimes, does anybody know the equation of a circle? What it looks like?
X plus y squared equals r squared.
Beautiful. So we're actually gonna figure that out right now. So the really interesting thing about these, and I want to say a real quick word. Why we call this conic sections? If I took a cone,
Because the shape is circle?
exactly. for the most part. And actually, if I took another cone like this, cool, I like it. So for me, that's pretty good. If I cut it straight through, cut it, just, and then picked it up and looked at it, it would look like a circle, right? It would look like a circle. Look at the top of a cone, if it's a decently made cone, well, now I want ice cream. If I cut it like this, now it's going to be an ellipse. It's going to be longer in one direction than the other. That's an ellipse, right? If I cut it like this, I'm going to get a hyperbola. I'm going to get a piece up here that looks like that, and a piece down there. That's a hyperbola, right? And then to get a parabola, I got to cut it so it only goes through there. So now it's going to look like this. It's really interesting. Now, of course, they do much better job. It's not hard to do a better job than that. On page 962, they actually show you the slices and what they look like. That's why we call them conic sections, because they are sections of cones. Cool. Circle, can somebody help me out? It's hard to do this without referencing the word, but can you define what a circle is?
Where the ends meet?
Say again?
The ends meet?
Ellipse does the same thing. So what's the fundamental difference between an ellipse and a circle? I like it. Circle's symmetrical. What's an important part of a circle?
Radius.
Good, the radius. Now what's the radius mean? Where's it start and where's it end? Not what it is, but where does it start and where does it end? Yeah, so it starts at the center and it stops at the edge, right? So if I want to come up with a mathematical definition of a circle, in reality, a circle is a collection of all these points, right? There are all these points on it. And what do all those points do? Every single point that's on my circle must do a specific thing. Why is that point not on my circle? But that point is. Because that point is the length of the radius away from the center. Okay, now we got something we can work with. Now math goes, oh shit, that's something I can sink my teeth into. What's a really good thing to call the center? And you know, this is all kind of nifty shit. This is kind of like transitioning you into pre-calc, even if you're not going to go there. Right, this just in case you have to. What's really neat is if I have a shape sitting somewhere, I can put a coordinate system on top of it any way I want to. And the way I want to is probably have the center at the origin. That makes sense, right? Now I could have the center off somewhere else. We'll talk about that later. But right now, let me just put this so the origin is right at the center. Make a big dot there. So what's the center of this?
0, 0.
0, 0. Kick-ass. Now what point is that? I love this question. You're like, what the hell do you want from me? Tell me exactly what point that is. That is the point.
On the circle.
I love it. That is the point XY. I love it. So I just picked some arbitrary point. It could have been anywhere. I don't care. They're all the same. The definition of a circle is the collection of all points that are equidistant from a certain point we call the center. Holy shit. Let me see if do they say what I just said in here? Blah, 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 blah. Blah, blah, blah. Here we go. Yes, the set of all points in a plane that are a fixed distance from a fixed point called the center. That's basically what I said. I love it. Kick ass. So it's in the book. You don't have to write that down. Page 965. But does that make sense? I mean, that's the quick way. Otherwise, you're like, how do you define it? A circle is something with a circular shape. No, he just referenced itself. Oh, shit. All right. You with me? It's sort of like looking up a ruby. What's a ruby? It's a type of gem. What's a gem? Well, a ruby is a type. Oh, holy shit. What the hell? All right. So we said that if it's going to be, and I could have made this there, every single one of them have to be r away from this point. So that's based on what formula can I use related to that? That is the what between the center and the point. That's distance. There you go. The radius is the distance from the center to that point. So what's the distance formula? Let's do it like this, d squared. Who remembers this thing that we should know? Gas. So watch this. So here's the, let me draw this a little better. So really what we're doing, and if you have to take trig, this is going to become a huge part of your life. For me, that's good. Yeah, it's really good, actually. You ever seen that people that can draw a perfect circle, they go, oh, something weird. That's not me, obviously. Normally mine looks more like Stewie's head, but that's pretty good for me. So here's the point. Here's the radius here, right? So look what I just did. I just made it into a triangle. So here's my x2 minus x1, all right? Here's x2, here's x1. Here's y2 there. Let me put it over there. y2, and here's y1. You got it with me? So this side will be y2 minus y1. This side will be x2 minus x1. And then the Pythagorean theorem takes over. That's where the distance formula comes from. So what is it for this thing? What is x2 and x1? What's x minus 0? So it's x. And what's y2 and y1? Y and 0. So y squared. And instead of saying a d here, what is that distance supposed to be? R. So we get x squared plus y squared equals r squared. That is the fundamental definition of a circle that is centered at 0, 0. Let me let you absorb that.
So this only works then if it's 0, 0?
Exactly. Now it's really stupid easy. Let me see if you guys remember. How did I take like y equals x squared? Let's start with that because you're used to it. How do I change where the center is? Well, let's look at how do we change where the vertex is. Where's the vertex for this right now? Come on, where's the vertex? True. Vertex is a point. 0, 0. If the vertex is a 0, 0, right? That's the unshifted parabola. 0, 0. How would, if I wanted the vertex to be at the point 1, negative 2, how would I change the formula?
Negative 2. Oh, wait.
Let me help you out a little bit. So how do I want the x to change? I want it to move up 1, right? You guys see that? It was at 0, now I want it to be at 1. So what do I put in there to make that happen? X minus 1, kick ass. Now what do I put out here to make that happen? Minus 2. Now, real quick, if I put a minus 2 there, could I add it over? You remember I did that earlier? When it's with the letter, it goes the opposite?
Yes.
All right, now, if I want... Look at me just going. One person said yes. I'm like, yes, everybody's got it. So hopeful. So if I... Right now, this center is 0, 0. How do I make the center become... Oh, I don't know. Let's make it 1, negative 2. How do I make the center become that? Yeah, x minus 1.
X plus 2.
Y plus 2. There you go. The center will now be at 1, negative 2. How do we know? Because this would shift everything over 1 and everything down 2. So the center is going to go to 1, negative 2. It's that simple. So tell me everything you know about this circle.
Center is at minus 5.
The center is where?
Negative 5, 4. Radius 5.
Is that cool right there? And then the radius,
5.
good, is square root of 25 is 5. I love it because that's r squared, right? I like it. I like it. And now watch how easy it is to graph this thing. You ready? You ready? Okay. Center is at negative 5, 4. Here's the center. Now watch. I'm not going to put a dot here. Why would I not put a dot there? I just put a little open circle there. If I put a dot there, I'm saying that that's a point and that works in my equation. No, the center is in the middle of all the points that work. So you can put a little x there if you want to. But let's not be better. Put a little x there. Bam. X marks the center. Now, and the radius here was 5, right? Shit, Jeff, why'd you do that to yourself? 1, 2, 3, 4, 5. This is the worst example. Oh, well, too bad, Jeff. You get the idea. So what's beautiful about this, even though the center is not 0, 0, circles have to be easy. symmetric in all directions, right? So once you know the center and the radius, you just count 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's the sides of it. It's 5 out in both directions, right? Because what's the radius tell you? From the center to a point on the circle. Kick ass. So I'm going to get the 4 main directions and then try to put a circle on top. So then 1, 2, 3, 4, 5. There's a point right there. 1, 2, 3, 4, 5. There's a point right there. And then and this is Stewie said now. Oh well, this is my circle. So fetch man. Sorry. Now if you graph this, if you look at your graphing calculator, is your screen square? You have a square to spare? Is your screen square? I think I was going to do that. Do you have a square screen? No, it's not square, is it? So if you graph a circle in your calculator, it will come out looking like Stewie said. So that's why I did that. All right, maybe. How the hell would you graph this in your calculator? I love it. See, I'm saying what you're thinking. Even though you didn't give me any indication of what you're thinking. How the hell are you doing it? What the hell? What's the only button you have to go tell the graphing calculator to graph something? What's the button you press?
Y.
Oh shit, so that tells me what to do. What do? I want to use the y equals button. I better do what with this equation? Well, we're not going to use this equation. This would be disgusting. Well, we can still do this. Let's do this one. That'll be yummy. All right. I've got to solve for y. And then I can graph it on my non-square screen. All right. Stay with me. Come on. You do it. Does this have an inverse, though? Does this function have an inverse?
No.
Why not?
Because we will not pass, for example.
Is it even a function?
No.
No, it doesn't pass any freaking. It doesn't pass a vertical line test. It doesn't pass a horizontal line test. You're just no good. Bad A. Looks more like an A. How do I solve this for y?
Break them.
It's a really, really good first thing to do.
Break them down for. Oh, square.
Subtract. I don't want a square root right now. That would so suck. What do you always do when you're trying to solve for a variable? You always get where the variable is stuck in alone first. I mean, that's the theme from this semester.
Minus x plus 5.
Subtract that thing. I don't want it. Alright, so you get y minus 4. Let me make that look like a y, and that look like a 4. There you go, John. Equals 25 minus x plus 5 squared. And then you square root. Now the minute you square root, what do you got to do? Oh shit. So how many equations am I going to have to plot? 2. So I'm going to have, and then I'm going to add 4. Is that cool? Try to save myself some time here. So I'm going to add 4 at the end. So it'll be 4 plus square root of 25 minus x plus 5 squared. And then I got to, so y1 will be that, y2 will be 4 minus the square root of 25 minus x plus 5 squared. You like that? If you don't, too bad. So let's try. Turn this guy back on. You guys, while this guy is coming up, you guys do what you can with that. We'll see how the calculator messes it up here. It doesn't do a great job. You'll see. Poor little calculator. Oh, what you got, Jeff? 4 plus. All right, so there's y1. And y2 will be 4 minus the square root 25 minus x plus 5 squared. Okay. So the first equation is the top hemisphere or semicircle. But what? So let's see. Is everybody with me on this? You guys with me? So if you got the newer version, the square root symbol extends. If you have the older version, don't close that parenthesis until the very end. Yay! So if I hit graph, well, let's do first. What was the lowest? We've already done some work. Well, what point is that? This is -5, and then it went down 5 from there, right?
Negative.
So this whole thing will fit in 10 by 10, I think. Yeah, this is 4, so that's 9 up there. So it'll fit by, so if I hit zoom 6. I told you it looks more like Stewie. Hey, it did a decent job. Alright, let's zoom in a little bit on this bad boy. Well, how can I change my window just so I have that sitting right here more? I can go from, x can go from -10 to 0, right? Let's give it a little more breathing room. Let's make it -11 to 1. And then y can go from -2 to 10. That would fit it in the middle with a little cushion on the ends. You guys semi with me? If not, just do that. Let's see. That's good teaching, Jeff.
If you're not with me, just do what I said. Okay.
There's a top part of football. Yeah, that's better. Now you can see what it has some trouble. So see where it has a little trouble? You see where it has some trouble? Where does it have some trouble? Right there, look at that. What is that? So you can draw his ears in, I guess. I don't know. But, I mean, that's just because of the resolution of the calculator. It only plots so many points. And when you get to the very end, you have to make your x change by, I'm not sure if you guys are going to move with me. You have to make your x change by really little amounts. Because, I mean, that's a literally tiny little area. Long story, too long, didn't listen. Resolution, that's why. Right? So you just can't help that. You just can't improve that. Sorry, student. To make this more circular, I don't know if the book talks about it, but you can change your dimensions to be a certain amount. I can't remember now what it's supposed to be, but that'll make it look more circular, but I know it's supposed to be a circle, so I'm okay. Now, is everybody with me so far, what we've done? Circles are basically easy. Their formulas are awesome. Does anybody know what the form of this implies that you might have to do for work? If I have a circle, I want to put it in that form because it's not in that form yet. What might I need to do? Complete the square. Cool. Twice. Shit. All right, Jeff, don't overreact. Twice is correct. So, my equation was this. Okay, that'll work. Your radius doesn't have to come out nice, but I think this one will. If I thought about this correctly. Yes? Are there any like, oh shit, my bad, make that a Y. Thanks, Kyle. I was like, alright, sorry, I just wanted all that to be Y stuff. How do I know that this, you can't answer this question, but there's a way I know this is a circle and not an ellipse. The basic difference between a circle and an ellipse is what?
Shape.
What about it? I like that. Yeah, it's not symmetrical, meaning it's a little longer in one direction than the other direction, right? And what that would look like is if there was any number here other than 1, it would be an ellipse. If these two coefficients are the same, and there's no other like terms I haven't put together, it's a circle. That means that in the x and y direction it goes the same amount. It's symmetric. But if that was a 2 and that was a 3, that's an ellipse. Bam. That's kind of awesome if you let it be. The very idea of what makes an ellipse different from a circle is what you see in the equation. That's awesome. All right. So let's do this real quick and then we'll talk about ellipses. So how do I complete this square here?
Add 4.
Good. Add 4. Is that cool? We've done enough of that one. And what about this guy? He needs...
25.
Now what did I just add? 4 and 25. All right, let me stop there for a second. Nothing different here, right? And we're back to having two sides of my kick-ass, right? There's not just f of x equals weird shit. So I get x minus 2 squared plus
X plus 5.
y plus 5 squared equals,
30.
see, that was nice. So what do you know about this thing?
So,
Center
is
2,
two
negative
and
5. Radius 6.
Radius is 6. Kick ass. Kick ass. If that was 37, the radius would be square root of 37, which is a little bit bigger than 6. All right, cool. We won't graph this one. We already did one. You graph this one the same way. Find the center, and then you count 6 out from it in all 4 directions. Make your circle, be it good or bad.
Did you find radius?
Oh, the formula for
So you just plug it back in?
whatever number is there is r squared.
Oh,
so say if that was 37, how would you graph that?
You just approximate square root of 37, 6 point whatever. Yeah. So the center is HK. Remember HK? We use that for standard form for a parabola. And the radius, incredibly enough, would be square root of r squared. Okay, yes. I don't need to actual value because I know the radius is positive. All right. So let's talk a little bit about ellipses, which is section 15.2. Oh, I do have a handout I'll give you in a minute. So let me, before we get into this, help me out here. Let's see if you guys are with me. If I had two numbers, let me see you guys can pull this, and both A and B are positive. You with me so far? And I add them and I get 1. What's the biggest that either one of them could be? I love that. You guys see that? There's no way that, and of course, let me put behind, this is all related to graphs and real number situations, so don't bring in any weird-ass complex possibilities. But the biggest that either one of these could be is 1. And when does this become the biggest? When does that become 1? When this is 0. I like it. Are you guys with me? There's no way this could be 2, because then B would have to be, and that's going against what I said there. Okay, good. Good, good, good. So here's the idea of an ellipse. So an ellipse would be like a circle. So let me give you, so ellipse, for example, would be like 9x squared plus 4y squared equals 36. Why is that an ellipse?
Because those coefficients.
Yes. Different coefficients, I like it. What we do to make it easier to analyze this, because what do you think, if I want to graph an ellipse, what are the most important points to find about that ellipse? So let's say the ellipse looks, is in this shape. It could be this shape otherwise, right? What's the most important points to find on there? It's a little weird. Yeah, the most extreme points, these 4 points, those 2 there, and those 2 there. That's the most important points to find on that ellipse, right? So that's why I was talking about extreme values, extreme situations. So just because it's a little easier to see what's going on, and actually there's a shortcut if I do this, I make this side 1, always. So how do I make this 1? That's insane. So what do I get then? Careful now.
X squared over 4.
X squared over 4. Be really careful about this. Plus
Y squared over 9.
Alright, now let me see if you guys can do this, and then we'll talk about the shortcut, because it's more important that you understand why it works this way. Based on what I said up here, why are both of these, must they be positive? Why must they be positive?
Because they're greater than
Because they're being squared, right? So the smallest they could be might be 0, right? But otherwise they have to be positive. Are you with me? They have to be 1. So the biggest that either one of them could be is 1. I like it. Cool. I like it. You guys, if you don't like what we're doing right now, you can just hang out for the shortcut. But I'd like you to just think math has got to make sense. It has to. So, when does either one of them become the biggest? When would this become 1 if this term was 0? So if y is 0, what is x?
4.
1.
Oh, 2.
2. Good. I'm waiting for everybody to get more on board. Why is it 2? Because 2 squared over 4 is 1. So if this is 0, that's got to equal 1. And if we make x 2, then that is 1. Alright, so I get, if y is 0, x is either, what kind of 2? It could be either plus or minus. So see how that's going to give me these two. And actually, this is going to be, you might be some of you guys see, it's not going to be this shape. So x will be plus or minus 2. So it'll be 2, 0, negative 2, 0. Those are the extreme points in the x direction. Now do the exact same thing in the y direction. Do you start to see a shortcut? You don't have to go through all the shit I said. What's y going to be? It's going to be plus or minus. Same way we just did. If that's 0, what's that going to be? 1. So y's got to be 3 to make it 9. So the shortcut is don't do all this shit. What's the square root of 4? Alright, cool. Negative 2 and positive 2. What's the square root of 9? Alright, plus or minus 3, right? And what's beautiful is, what letter is that with? Do you understand what I mean? It's with the y, isn't it? So that's the y direction. So that's going to be 0, 3, and 0, negative 3. Let me let that sink in. This is almost too nice. And then you plot those points, right? So it's very similar to a circle. Circle's a little easier because it's the same amount of distance in all directions. Here I can't find a distance. I actually just find the 4 points. Because I can't find a distance because the distance changes. It's really long here. Or in this case, it's going to be longer there and shorter there. Right? So if you plot this, how does it end up looking? In the y direction, they're going to go 3 up and 3 down. In the x direction, 2 over and 2 down. Right? And why is the center 0? 0. Well, how would I know it's not 0, 0 if... Why was this center not 0, 0? Because there was stuff in there with the x and the y, right? Well, here, what's with the x? 0, nothing. 0, 0. So that's why the center is 0, 0. This was x minus 1 squared. The x would have been 1 for the center. Same way it was over here. Okay. So then all I got to do, now, was that hard to do? No. So 2, negative 2, 3, negative 3, fill it in. Whee. So that's Dewey laying on his side. I don't know. This one, well, this is really easy. If you want to plot it in your calculator, do the same thing we did earlier. It's a little bit easier. There's less stuff going on there, right? You get y1 is the plus and y2 is the minus. Yes, no? You guys cool with that? You can plot this the same way we did. Just solve. I would start maybe here. Subtract 9x squared, divide by 4, take the square root. y1 is the positive 1, y2 is the negative 1. It'll do the 2 parts of the ellipse. Okay, maybe. All right, you guys do this. Oh, what you got, Jeff? I don't know. So why is this an ellipse and not a circle?
They're not.
Yeah, different coefficients. Why is this an ellipse and not a hyperbola? We don't know, Jeff. What the hell's a hyperbola? Shit. Hyperbola is going to have a minus sign. Yeah, so the x and y pieces will be different signs. Here, I'm going to pass this out while you guys are doing that. I hit them up already a little bit. Sure. Yeah. So the same coefficients.
Yeah, so this is 9, still this.
You wouldn't need to. I would divide by 9 then. So the circle doesn't have 1 on this side, it just has r squared. Right? But the ellipse and the hyperbola, the numbers I need to make it easy, if I make it equal to 1, I can just see them. They're the square roots of the bottom of something. Bam. Who? Yeah. Okay. You didn't get one? Okay. All right. So what's the first step here?
Divide by 81.
So you get x squared over 81 plus y squared over 9 equals 1. So in the x direction is going to go. So we'll officially now. Here's what I don't like, and it's not the book's fault. If I try to make this general, they have to figure out what to call A, what to call B. I don't give a shit what A and B are, because whatever numbers with the x, that's the x direction. Whatever numbers with the y, that's the y direction. It's going to be the same for hyperbolas. But there are some other formulas too that depend on what A and B are. We'll see in a minute. But here we'll officially call this A. This is A squared. So if you see on my handout I just gave out, the formula for an ellipse is x squared over a squared plus y squared over b squared equals 1. That's the form of an ellipse. So what's A then? 9. What's B? 3. Cool. Doesn't really matter who you call A and B. It doesn't matter if you call this D and this Y. Gives a shit. They are just the amount you go in that direction.
Plus minus, right?
Well, in this case, they're distances. So, yeah, it says 9 up and 9 down. 3 up and 3 down. Yeah. So now if I want to go plot this, where's the center? Did it go the right? Yes, it did. Yeah, the center is 0, 0, so that's where I count from. We'll do one here in a second that's got a different center, just to make sure everybody's with me. So I'm going to go 9 in which direction? Good, left x direction. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Some of you guys really should get graph paper before your next class, just so you don't drive them insane. 176 is big on graphing, so I know it might seem like I'm being picky, but that is nowhere near as picky as your next teacher should be, if you get a good teacher. And then I want to go up and down. 3. That's why I did that. And then you just fill in. How's that? No, that's all right. Sorry, Tim. Somebody sat on one side of my football. That's all right. This is the football that was used in the Super Bowl, yes. Just get that out of the way.
Potato.
The Patriots. I hate the Patriots, but we'll stop there. How many other ways can you cheat? We'll find out. We'll find out. We won't stop at videotaping other teams. All right. So if the equation would have been this instead, how would I have changed things? If the equation would have been x minus 1 squared plus y plus 3 squared. So everything's the same except that.
Right.
Yeah, so I would have just done, is that the one I had to go crazy? Yeah. I would go right 1, down 3. Cool, that would be the center. Oh, that's screwed, sorry.
Then you drop.
And then from there, I would count. I'm not going to actually do it screwed. You count 9 up and 9 down, right? 9 in the y in the x direction, and then 3 up and 3 down in the y direction. So this, you still do the exact same thing. You just count from whatever the center is. It's that simple, right? That's simpler than you could have hoped for. Uh-oh, what's up?
So, what are we looking for?
So up 1, down 3, bam. That's the center.
No, that's the center.
Well, that's the center, right? An ellipse doesn't really have a center, but there's still the center of where I count from. Let's say it like that. You with me? So let's talk about what an ellipse has. An ellipse actually does not have a center. It sort of has two centers in a way. It's got two foci. Right? Whereas a circle is like the two foci. If I have an ellipse like this and I smush it, the foci come together and become the center, one thing in the middle. So I don't know if you realize this, but every orbit of every planet, none of them are circular. They're all elliptical. Where the sun, so if I have an ellipse like this, the foci, oh, that's beautiful. The foci might be here and there. Let's just use a letter F instead. Here's the focus, there's the focus. So for a planet, for the Earth, the sun is at one focus. So if we're here, we are closer to the sun than we would be over there. Right? So whenever you hear that 93 million miles thing, that's an average distance from the Earth to the sun, because it changes. We're not always as close or as far away from the sun. Freaky shit. We're going a little faster here. It's like a gravity assist. Whee! And then we slow down, then we get fast again. Okay, all right. So how do you get the foci? What's the formula for the foci? Let me see what they tell you. Did they get into that? Well, shit. Maybe I'm going further than I need to. They don't get into that, those dorks. Well, I'll show you anyway, just so you know. So here's the weird thing. Do you see how this equation has a plus in it? And remember what I said earlier, the hyperbola equation is going to have a minus in it. The equation for the focus, we're going to give the focus the letter C, just because F would have been too easy. Sorry. The formula for the focus, you see how I gave this A and B stuff? That's the formula for the focus. What's kind of evil about that equation? It looks like Pythagorean, except it's got a... so that's where this comes in. If you're dealing with an ellipse, that's got a minus. If you're dealing with a hyperbola, it's got a minus here. Its focus equation is going to have a plus. And why does this minus make sense? Where are the foci supposed to be? They're supposed to be inside the ellipse. So if this distance is A, this is going to be smaller than A. So if I subtract it a little bit away, it will be inside. All right. Woo! So where's this guy's foci? Let's deal with this guy. Where's this guy's foci? How do I find the foci? I just like to say foci. C squared equals...
9 squared.
Yeah, 9 squared. You can actually look up here. Right? These are the A squared, B squared. So 9 squared. So 81 minus B squared, 9. So C squared equals 72. So C equals the square root of 72, which you can approximate. I mean, you can... Huh?
36.
Yeah, I mean 6 rad 2, which is approximately... 72 squared root of 72? What is that? 8.4?
8.4.
Huh?
8.48.
Like 8.50? Okay, good. All right. So see, now watch. So where is it? 1, 2, 3, 4, 5, 6, 7, 8.5. So it'll be right there. So I'll put a little F, not a point, Jeff. Put a little F for the focus. So down here, there'll be a focus right there. Cool. I like it. So if I smoosh this dude, the foci would rush to the middle. If I smoosh it enough so that it becomes a circle, they both meet in the middle. Then it's a nice circle. So a circle has the two foci that become one center. Yes?
So that's the distance they are away from each other?
No, that's the distance away from the center.
Oh,
To the focus. So I got F, I got a C was 8.5, so that's how far I go from the center out.
Okay.
Good. I think this is a good place to say some good news. I wanted to hold on to this because I was afraid more of you would leave if I said this too early. If you've looked at my math lab since this morning, you'll see that 15.2 and 15.3, I have called them extra credit because they are. Look at me forcing you to sit here and listen to stuff you might not otherwise have listened to. So I am going to talk about hyperbolas, but I thought I'd say that just so I can see who's got the balls to leave now. So very quickly, I know at least one of you guys have already done chapter 15 homework, which is awesome. So you've already got some extra credit, which you might not have really needed, but oh well, it's there. So very quickly, that's why I don't mind going kind of semi-quickly. Plus, my God, this will give you guys time to focus on actually finishing earlier homework, right? Which will help you on the final. All right, so real quick, a little bit about hyperbolas, and then we'll head out. So hyperbola, just jump to the main idea here. It looks like this. Thank you. I don't know if you guys heard that. There's clapping somewhere. This. So you guys
Focus will be processed.
try to find the y-intercepts. Take a second, try to find the y-intercepts. How do you always find the y-intercept? Always. You made x 0. So take a second, try to find the y-intercepts. No, come on, don't. You got to do it. Your brain is trying to save you shortcuts that are all wrong. If you make that 0, this is going to be positive always, right? So you're assuming negative positive can equal 1. Does that make sense? There's no way negative positive can equal 1. Unless you use complex numbers. We're not going to because we're dealing with a real plane, right? So are there any y-intercepts? What did you say? Oh, yeah, are there any y-intercepts? No. So this hyperbola is going to look like this. Because there are no y-intercepts. There are 2 x-intercepts, though, aren't there? Now you come in. What are the x-intercepts? Plus or minus 2. Alright. So now watch. It's kind of cool if you think about it this way. And now that I've already told you it's credit, extra credit, maybe you don't have the full attention